Da-da-da. We are live, Paul Smith Goodson.
Good morning. Good morning.
How are you doing?
Doing great.
Excellent. And good morning to everyone jumping in and joining us, or good afternoon or good evening on this cold winter day from Paul is in Austin, the Austin area, and I'm up in Arkansas today, which is even colder. So welcome to the Moor Insights and Strategy Data Center Podcast. I'm Matt Kimball, and I am joined by the ever wise and growing wiser Paul Smith Goodson, the brains behind the operation. We are here to talk all things data center. Missing from today, you might realize, is Will Townsend, our compadre. Will is driving back from Missouri, or as we like to say, Misery, to Texas. So he's unable to join us today. So drive safely, Will. We're going to talk all things data center. Before we get going, please listen to this disclaimer carefully. We are super smart technically, and we know a lot of things, but we are not financial experts. Do not take anything we say as financial advice. If you go out and make trades or investments based on what you hear from us, shame on you. Right, Paul?
That's all right. No, don't do
that. So sit back, enjoy, and we're going to have a fun time. I think we're at episode 39. We're missing a banner today, but I've always liked the number 39, as 9 is cleanly divisible by 3. That's all I get for 39. I don't know if you have a enjoyment of it or not, but that's okay. We're going to talk about a lot of things today: Microsoft, Hewlett-Packard Enterprise, Google, and then some news that Lenovo made a couple weeks ago with its intent to acquire storage startup, high performance storage startup, Infinidat. Paul, what do you got going on today? Anything? You doing well?
Doing good, yeah.
Yeah.
Happy news. We got a new quantum modality. Topological is in the mix now.
Right on. And you also have something else new, right? Is that perhaps a great-grandchild? Is that right?
Yeah, that's right. A little grandson, great-grandson. The first of our third generation.
That is awesome. Congratulations. I hope everybody's doing healthy and well. Anyway, so let's jump in with your new modality discussion. We're going to talk 2D quantum. Is this a Microsoft discussion we're having?
Yes, it is. Topological quantum chip. They had a little false start back in 2018 and a little problem with data, and they retracted the paper on that, but they stuck with it, and I'm really glad that they did, because topological is really an interesting modality and technology. It has a lot to offer. They've got a new Nature paper that was published a couple of days ago, and it unveiled a Majorana 1 chip. It's the first topological chip with topological core architecture. So looking pretty good. They're expecting to scale this up a lot faster than what I anticipate, but we'll see how that goes. They also developed a new material called the topo conductor, and it's a topological superconductor, and it helps create these states of topological matter that you need for the processor. And it's been built like on an atom by atom basis. They used iridium arsenide and aluminum, and that's what they're using to produce these Majorana particles. It's not really particles; they're quasi-particles. Mm-hmm. And they're error resistant. The qubits are error resistant, and they're less sensitive to noise and stuff like that. The architecture that they've built, they've got a roadmap that they built scaling it up to a million qubits at some point or another. They say it's going to be years rather than decades to do this, so we'll see. The real glue to this is the something called anyons, and it's kind of hard to explain topological without understanding these. I think I'll use the time to do that. Imagine that you had a pair of shoes that they were connected in some magical way together, and regardless of how far apart you took these shoes, you could look at one and then know the state of the other one. But you can't really think of them like a shoe at a time. You have to think of them in terms of their relationship to each other, and that's kind of the way that these topological qubits work. Instead of using normal like bits of 0 and 1 like normal qubits do, they store information across pairs of quantum quasi-particles, and those are called Majorana zero modes, and that's what produces. These are really they're not real particles in the way that we think of them, but they're quasi-particles. So it's the way that they've got of encoding information in the qubits, and it's very stable and everything. These the quasi-particles are they're really kind of hard to explain. They're collective excitations that happen in certain topological superconductors, and it's the collective behavior of electrons that kind of mimic the properties of these Majorana fermions. They appear at like the edge of a topological superconductor, and they're in the form of basically like a 2D object, if you can imagine that. And the reason they're so stable is that in a 2D form, they're able to braid these topological qubits. So that just think of a knot, like maybe if you got a tattoo of a knot on your arm, trying to untie that knot, that 2D knot would be pretty difficult. So you kind of get an idea of why these things are so stable.
Yeah. So
were you ask something?
So answer this question for me. From a person who's out there who's like in IT and thinking, yeah, I'm hearing about this quantum thing, and I know it's coming, and I know there's going to be a real impact to what my data center looks like, what my world looks like. What is the impact of what Microsoft has done, kind of from a practicality, usability, I guess, kind of in the real world? What does this all mean for folks?
Okay, well, it is actually a real breakthrough, being able to create and control these Majorana particles, quasi-particles. That is a real breakthrough. When you compare what they've done now with like IBM or Quantinuum or IonQ or Atom Computer or those guys, the other ones are far ahead of them in terms of quantum capability. But if these are what Microsoft believes that they are, and if they have the ability to control errors and things like that, and over the long haul, Microsoft might be able to catch up with the quantum capability of the other companies. Right now they're far behind, just from a quantum capability standpoint.
Yeah.
Breakthrough is like, they're on the starting line of race cars, and the other race cars have revved up their engines and they've taken off. And Microsoft is still on that start line, spinning its wheels, but when they get traction, they can zoom ahead of these other guys. So that's kind of the situation they're in now.
And when you use the term capability, do you mean kind of real world application of quantum, or do you mean, because there's like the science fiction element to this, and then there's the like, here's, this is going to have a real impact on what we do, from a computing perspective, right? And those are sometimes two different, there's a lot of what you can do, but it's so far ahead of where the world is that it, maybe doesn't have as much relevance.
Everyone knows the big obstacle in quantum computing right now is error correction.
Mm-hmm.
We made a lot of progress in terms of error correction, what they're doing with logical qubits. This system does not depend on error correction as we know it. It's in the inherent capability of the technology and the way that this operates. Like I said, it's like a 2D knot.
Yeah.
It takes, it's pretty hard to untie a knot. And these knots in this technology basically act as quantum gates. And they're also it's very hard to untie these knots, which would be the result of an error, or noise or something like that. So that's one reason that this technology is so important.
Got it. Well, I'll tell you what, the more I listen to you, the more I'm convinced that we're going to live in a science fiction novel within the next 10 years. And I don't mean that in a flippant or funny way, but as quantum realizes its potential and finds adoption in the research community and the scientific community, it seems like the possibilities are almost limitless as to what we can do.
I've had probably either 3 or 4 briefings on this over a period of years, and every time I've seen a briefing, I think, man, this is a long ways off. But the next briefing that I got, I would think, well, it's not quite as far off as I thought.
Yeah.
The last one I had, I knew it was close.
That is
the announcement.
Crazy and exciting at the same time.
Yes, it is. I'm really excited about this, and I think everybody in the quantum world, they're probably also excited about it. It's not instant, not an instant million qubits, but it's got the shoes to get there.
Well, I think as disruptive as AI is, quantum, it's not even, quantum will be exponentially more disruptive to the market. But anyway, all right, let's move on. All right, HPE Gen 12 ProLiant launches. Why does this matter to anybody? So it's interesting, the server market by a lot of folks, especially because of AI, has some have looked at it as more of a commoditized kind of play, with more of a focus on what sits inside, right? Those NVIDIA GPUs, even less about the CPUs, but more of those NVIDIA GPUs that are sitting inside, and in some cases, those AMD GPUs. But that's not the case, right? AI is one workload that runs in the data center or in the cloud and impacts the data center, and eventually data center. But there are a whole lot of other workloads, and security is still a concern. Performance is still a concern, cost is still a concern, and the cloud is still a concern. And that's what HPE delivered with or what it claims it delivered with Gen 12. So 3 big pillars for HPE with Gen 12. One is security. The other is efficiency, operational efficiency, and that AI is tied into that. And the other is kind of manageability and power efficiency. So from a security perspective, new ILO 7, I'm just going to go through the news and then give my take. New ILO 7 with what they're calling Secure Enclave, which is a quantum resistant mechanism for storing passwords and and digital signatures and firmware. We'll get into that in a second. Operational efficiency, especially around AI. They've delivered its next generation CPUs from Intel, their latest Xeon 6, along with the kind of the latest from a PCIe DDR perspective. So really great performance. And then from an operational or from a power and operational efficiency, there's manageability, new compute ops management capabilities, new monitoring capabilities, and like incredible opportunities for sustainability gains as far as consolidation goes. So I spit out a bunch. What does this mean? Really, what it's about is HPE is taking its ProLiant platform and it's focusing on the areas where it thinks it can still deliver a lot of value into the enterprise. Security is a biggie. And while everybody talks about, and if Will was here, he would tell you that, it's all about MDX and protecting at the network level. Mm-hmm. It's important. But if you don't secure infrastructure at the very lowest levels, then you can never have a true zero trust architecture, right? It's like you've got to kind of look at security across multiple vectors. And that north-south vector, it's got to start as far south as possible. And that's what they do with Silicon Root of Trust and what they've done with the Secure Enclave. Really like what they've done. They're adhering to the most strict standards as far as FIS and NIST goes. So super, super excited about that. Manageability, I really like what they're doing. It's really not part of Gen 12. It's really more around compute ops. I guess that's... but I really like what they're doing from a manageability perspective, kind of leaning into AI-driven automation and kind of, I would say at that level 2, level 3 of autonomous compute, really cool. And from a sustainability perspective, this is as much a function of the CPUs as it is the platform, but great consolidation ratios allows you to drastically reduce your server footprint. Couple of things in there that I wish the company would give some clarity on. Gen 12 is only supporting, or is only its portfolio is only inclusive of Intel Xeon 6 right now. There is no AMD alternative to Intel, and I don't have clear direction on whether they're going to do an AMD version of Gen 12. From a performance perspective, it really doesn't matter because you can stick AMD's latest Turin EPYC processors into Gen 11, and that's what they've done. So fully available. So you get all that goodness of AMD in Gen 11, but you're missing out on the security enhancements that HPE delivered. So is it a big big miss? No, but I'm just kind of curious as to what the thinking is there. But overall, a great platform. Sorry, go ahead.
Yeah, one thing that caught my eye was the quantum resistant features and quantum. Post-quantum security is an important issue right now. It's not something that you can hear about one week and then have a complete fix the next month.
Right.
I mean, takes years to get a large organization in a position where they're quantum resistant. Yeah. And there's a lot of work to be done in terms of putting in systems that monitor the status of all these devices and send out alerts when there's been an intrusion, or if one of the devices is not providing the proper security. Yeah. But it takes several years to do this, and I think that's an important feature that they've got built into this.
Yeah, I'm glad you say that, because there is a lot going on the quantum safe side, and you're right. And it's a lot of folks will say, well, does it apply to me today? And there's some things they're doing that possibly do. But if you think about, and let me just 2 seconds or 2 minutes on this, Paul, and then I'll shut up on it. But for you folks in IT that kind of listen to this and think it's a little futuristic, quick explanation of what it is. So if you think about some of the encryption that's being used today, like Diffie-Hellman and some of these different kind of keys or key relationships and certificate solutions out there, they use encryption algorithms or encryption keys that are super secure, super tight. Well, within quantum, there's this thing called an algorithm called Shor's algorithm, and it's a math it's a way to solve math problems. But what it does is it allows bad people to take those super tightly encrypted solutions and de-encrypt them very quickly. And I don't mean in a matter of days, I mean in a matter of seconds. So, there are different ways of going about it. Some of them are kind of like just breaking that typical cryptography. Some of it is harvesting and then saving for later so you can attack later. There are all kinds of different ways that people are looking at kind of these different algorithms to go in and attack. So, it's something you should be concerned about today. It's certainly something you should be concerned about tomorrow. And to what you said, this requires a lot of deep thinking and a lot of serious kind of redesign to support. The fact that they've been thinking about this for, you got to think, a couple of years, tells you that they're far ahead of the curve and will continue to do that. And this is an area where HP has always led. Gen 10, they were the first to do silicon root of trust, and they've kind of built on top of that through Gen 10 plus, Gen 11, Gen 11 plus, not just silicon root of trust, but all the way up the stack. So really great job they've done. I'll be curious to see how the market responds to it. Yeah. Anyway.
IBM has got probably one of the best systems right now for post-quantum cryptography.
Yeah.
And NIST has come out with, post-quantum algorithms now approved of that.
Yep.
And they're working on the next batch.
Yep.
And as you saw with what Microsoft is doing, there could be a breakthrough at any time, and it's not that hard to break RSA encryption. I mean, it is from a compute standpoint, but technically, if you've got the tools, it's not that hard to do. So.
Yeah, kind of scary. Anyway, all right, moving on. AI Science Buddy. This is certainly yours because it's a really cool headline. What is an AI Science Buddy?
Yeah, I kind of lied here. It's really Google co-scientists. So you've got an AI sitting there that's your scientific buddy that can help you with research. Google just recently put out this co-scientist capability, and there's a lot of deep research AI models that are emerging right now. OpenAI, Perplexity, and a couple others. They take a long time to run. They do a lot of deep research on the internet. They go through papers, and they're very innovative. Google's co-scientist is a multi-agent AI system built on the back of Gemini 2.0.
Okay.
And it literally helps scientists generate novel hypotheses and helps to accelerate discoveries. It takes care of, there's challenges when you're trying to navigate all of this scientific literature and trying to integrate all the interdisciplinary insights. You take CRISPR as an example for that. And the co-scientist it's a collaborative tool. It uses the scientific method, and it's got specialized agents built into it. It's got a generation agent, reflection, ranking, evolution, a couple other agents that work on it. And actually goes beyond just kind of going out and gathering up literature to review information, and I mean it does a lot deeper stuff than that. It'll parse natural language into, create research plans. It has a supervisor agent that does that, and then that supervisor agent allocates the task to the specialized agent. It's got feedback loops in it, and it's got time test compute. By the way, I just a side note, I registered a year or so ago. I registered a time test compute.ai, thinking that sometime that might be useful. But time test compute is used in a lot of different a lot of different AI applications. So anyway, they use that to
for sale. Are you saying it's for sale? Are you saying it's for sale?
No, I'm not. I just just sent you. No. When you register an AI domain, you do it for 2 years. So I think I still got it. I'll have to go check.
Of course,
I got a couple of them in that area. So
I mean, this is effectively managing your science projects for you, your research projects for you.
I mean, it's got it passed the GPQA benchmark test. That's the I forgot what it stands for, graduate level professional question and answering. And these are like PhD level questions that I asked on this test.
Wow.
And the co-scientist, I think it outperforms every other model out there. So, I mean, it's amazing. I ran a couple of tests with Perplexity, but I wasn't too impressed with that. And one thing that's really amazing on this, and we'll cut this off. One of the examples that I worked on is something called antimicrobial resistance, and looking at how genes are transferred from microbes to mechanisms in the body that go around and wipe these out. And I read this morning that it took co-scientists 48 hours to develop an answer on how that happens, and it happens to work on these microbes. Or the body steals the viral tails from the virus and incorporates that and goes around and duplicates that among the body. But anyway, it took co-scientists 48 hours to develop a solution for that, and it had taken Imperial College 10 years.
Oh my gosh!
To develop the same solution, and that solution had not been published yet.
Oh my gosh!
The co-scientist was able to independently reach the same conclusion about bacterial antibiotic resistance as that group of researchers did for two decades.
Was that based on some of the work of those?
No, it wasn't. That work was not.
I know it's not published, but there's public.
I think it came up with 5 different solutions, and that number 1 solution was the right answer.
Wow, that's crazy. That's crazy. The what do you see? So with that said, how do you see this impacting kind of, the research labs that populate so many universities and kind of lead to these breakthroughs? I mean, is this you're replacing teams, or is this aiding teams?
I'm not going to replace teams. It's going to certainly accelerate discovery. We're going to be seeing things that would have probably taken us 50 years to find, because these programs are just getting better and better. And the use of agents, the way they've got the agents that are specialized, is a lot more efficient. And they come back and they kind of like debate among themselves to come up with the best answers. And we're just going to get better and better at this.
But you don't think it takes, say a team of, say 20, professors and graduate and PhD student level students, and cuts that team from 20 down to say 5 or far fewer because it's doing a lot of the legwork that you would normally require on these folks to do?
It might very well. But we're still going to need those researchers, and
Yeah.
they're not wasting their time doing research, going out and gathering information from the internet.
Right.
And their time doing really productive research.
More high value. Yeah. I agree with you. Oh, that's fantastic. And that's Google's co-scientist?
Yeah, Google co-scientist, yeah.
Is there a link to that? We'll put a link to that in the show notes so if people want to kind of play around with it. That is cool stuff. Right on. All right, let's go. We have one more topic to hit on. This is news that happened a couple of weeks or a few weeks ago, and we had been meaning to talk about it, but kind of got sideswiped by Stargate and then DeepSeek and a few other things. But I want to touch on a move Lenovo just recently made by acquiring enterprise storage, high-performance storage company, Infinidat. So, and by the way, Lenovo just announced their earnings yesterday. Super strong growth in its infrastructure services group. So the servers and storage and so on and so forth. Incredible growth. They're tracking back to positive profitability. Lots of activity in both the cloud and AI. So hats off to them. But a few weeks ago, they made an announcement where they were going to acquire Infinidat. Now, Infinidat is a company storage company that focuses on. There are different classes of storage, right? There is storage we need at home to back up pictures and videos and important documents. And then there's storage that's used in smaller companies and then bigger companies and then really big companies. Different classes of storage serve each one of these markets. And then if you add another kind of axes on that, there's a performance axis, right? So I might have a really big company with a whole bunch of data that I need to store, but I'm just archiving it, right? I don't need it to be super highly performant. But then there's I need to get access to data fast to feed AI, to feed HPC or other business critical workloads. So there's the scale and then there's the performance, right? And if you kind of follow where those meet, Infinidat's in the upper right-hand corner. Super performant, lots of storage. It's got to be super reliable. Got to be really fast. Really great company, Infinidat. Lenovo, though it has been in the storage business for some time and has done very well, kind of up that scale to a certain level. When it gets to like the really high performing storage that kind of is, call it more niche-y, they haven't really played in that. The challenge is this: when an enterprise goes out and buys a storage environment, they look for their most demanding workloads, and then everything kind of cascades off that, right? So I'm going to make a judgment or a purchase decision based on my most performant workloads. Well, that has excluded Lenovo from the equation for those enterprise customers because it didn't have a solution outside of its partnership with NetApp. So enter Infinidat, right? Oh, and by the way, as an enterprise IT person, the decisions I make around storage, a lot of times I'm going to tie those directly to my servers too. I just want one vendor to deal with as much as possible. So if I'm going to buy, Dell for storage, I'm probably going to buy Dell for my servers as well. Same for HPE, right? So this has excluded Lenovo from having a more competitive position in the enterprise. So they went out and announced the intent to acquire Infinidat. I think it's going to close second half of 2025, or anticipated to close second half. I don't see any roadblocks to them doing it. It doesn't put them in any kind of monopolistic kind of position. Really good acquisition for Lenovo. The Infinidat technology is good. It's got a really good group of folks behind it, both from an engineering and go-to-market perspective. And I think Lenovo can leverage this Infinidat business that has done very well in the Fortune 500 to start motivating some server sales, right? So you can see where this grows Lenovo's overall enterprise footprint pretty significantly, if it executes against this strategy properly. Yeah, I've been kind of trying to think about what the downside to this is. I don't see it yet. This is a move that fills a gap in Lenovo's enterprise strategy. It fills a big gap, and it does so in a way that that is non-disruptive to its customers. So non-disruptive and also just purely additive. It's not like someone's going to go, wait a minute, you bought Infinidat. What do I? There's not a lot of overlap in what Lenovo has been offering. So good all-around acquisition. Excited to see what happens. Going to be curious to see how Dell and HPE respond to this once Lenovo has this in its portfolio.
Now, I want to ask you a question I have.
Yeah.
When you've got like a high-end storage provider,
Mm-hmm.
It seems like their revenue is tied more to innovating to remain relevant in the market,
Mm-hmm.
and it is to worry about new customer acquisition. Is that true or not?
Yeah. I think in most cases, yes. Excuse me. You kind of, to what you were saying, if you build out those two axes, this is backwards on camera, right?
Yeah.
And you go up to the upper right? That's a smaller number of customers typically that have very specific performance needs, right? So while even if you're acquiring new customers, the market size is not, it might be bigger from a dollar perspective because it's a lot more expensive. But from a volume perspective, it's not nearly as big. It's kind of the downstream impact that has that becomes really interesting, right? It's like servers. If you sell servers into high performance computing kind of workloads,
Mm-hmm.
right? The number of customers is a lot smaller. It's more expensive. Maybe the margins are good in some cases, not good in other cases. But it's the downstream impact of that really kind of is interesting to a server vendor or a storage vendor.
Yeah.
Yeah, you're right.
The other question I had, you said that merging a software company like Infinidat with a big hardware company like Lenovo,
Mm-hmm.
the momentum can stall if it's not really handled right.
Yes.
That really is kind of a market-wide issue. That to be successful, you got to be pretty agile operationally, and got to be sensitive to cultural issues and not just technology.
I wholeheartedly agree. It's funny. I mean, you've been in the technology business. I've been in the technology business. I've worked for hardware companies. I've worked for software companies, and I've worked for solutions companies. And there are cultural divides between these different types of companies. Not only that, kind of separate markets, different cultures as well. It's probably the biggest challenge, Paul, that any company has when it goes through these acquisitions is like technology you can figure out, right? Well, you can, but there is a direct line from how well the integration of technology is to how well you integrate at the cultural level, right? Because these people have to work, these teams have to work together, and they have to kind of get on the same wavelength and in the same room, metaphorically speaking, for this to really kind of be effective. Otherwise, you never reach the full potential.
Mm-hmm.
Yeah. I know the folks at Infinidat, great group of folks. I know the folks at Lenovo on that storage team, Stuart and his team, great group of folks. I think knowing kind of the culture of these two companies and the leadership, I think it's going to be it's going to do quite well. You're going to see a very compelling overall solution come out of this marriage. So anyway, hey, listen, we've talked forever on just a few topics. Without Will, it went a lot quicker and it was a lot more informative, I think.
And more fun.
More fun. Sorry, Will, we're just kidding. But hey, thanks for taking the time, Paul, to kind of talk through some of this stuff. Always interesting to chat with you. And for folks that are listening in, again, across the country, across the globe, thanks for listening in. Again, what we talk about it's informational and there's an entertainment aspect to it. It is not in any way meant to be perceived or accepted as investment advice or guidance or anything along those lines. So please take everything we say with a grain of salt. And Paul and I have both written about and talked about everything we talked about on this podcast. In our show notes, you'll find the links to go learn more about what we've talked about. So thank you for listening in. If you liked us, please click the like button and subscribe. And we'll talk to you in a couple of weeks. Thanks, Paul.
Yeah.